All right, guys. Welcome to Unit 5, Server Hardware and Troubleshooting. You guys have one more unit after this and you're done. So, in the home stretch now. So let's get started with Unit 5 here. Unit 5 here, we're covering hardware, troubleshooting, and maintenance. Give me 1 second because I hear my fan going off. Sorry, I hope you don't hear that. My tower's been a little funky. One of the wires is hitting the fan. Not important. 1 second. All right, it stopped making that damn noise. And it just started. Nope. Okay, we're good. So, when picking out a server, next slide, how do you pick one? What makes you define what you want in a server? Well, you need to understand that your server can fill a bunch of roles, which you have seen and implemented at this point in time. So there's a couple things I put on here. Servers can fill hosting business emails and databases, sharing and storing files, providing remote desktop connections, hosting websites and applications, etc. Performing system and data backups, all these things. You got to consider your server location and maintenance, and you got to calculate a budget. Those are all the things that go, or you should be thinking about rather, when you go to purchase a server. But the other thing is hardware. It's great that you can spec all of this out to what roles you want, where you're going to have it, how you're going to maintain it, and how much you're going to spend on even purchasing it and installing it. You might just do the install yourself, or get a third party if it's more affordable, whatever have you. But depending on the server you pick, it comes with some nuances. So there's some requirements, which I'm not going to get into that much. I'm not going to have you guys spec anything on too crazy. There'll be an exercise at the end of this unit, but I'm still writing it. So I'll get there when I get there. It's only Tuesday today. So let's talk about hardware. Originally, the original form of a server, if you want to call it that, were these things called mainframes. These things are huge. They're the size of a fridge. I personally have worked with them. This is a more modern one. It's a Z Enterprise by IBM. This is what they look like. And mainframes date back to about 1950, 1960, around technically the birth of computing, or personal computing almost. It could be traced back almost to, what's his name, Alan Turing's math machine during World War II. It's kind of where computers and math kind of came together at that point. It's considered a major point for computing. Another thing you can think about if you're just curious about it is, good Lord, what was the name of that bomber? The Strata Fortress. Strata Fortress from World War II. I forget that. B-29. There you go. That had a computer aided aiming on all the turrets. So that's something you can look up later down the line. But servers didn't really take off until about the 90s. And they kind of took off in the sense of everything was a tower server for a while. Then rack servers started coming out shortly after that. And now today's servers range from all kinds of forms. And I'm going to put 3 forms up right now. Or 2 forms for first and the last form. Then there's actually 4 forms when I think about it. One's virtual that you guys have done. So let's talk about different kinds of servers and server hardware. So this is just the overview of what they are. A tower server looks exactly like what it says. It's a tower. You can slide the drives in and out, add more memory space, as you go. Then you have these rack servers, and those are used more, itchy here, more for business, more in like government settings use those a lot more. Big businesses use a lot more. It's usually cheaper, and I'm saying that in terms of space, to have rack servers because you can mount a bunch of them, versus these tower servers are bulky. They're about, trying to figure out how big they would be. Comparable. You've seen those tower fans at Costco? That's about how tall they are. They're about 2.5 times as wide, and depth wise, they're about 3 or 4 of them just stacked front to back. They're about that big, so they're clunky. So a rack server here, you can have, how many they got here? It's hard for me to see. 1, 2, 3, 4, 5, 6, 9, 10, 11, 12. Looks like they have 12 rack servers bolted in that one frame on the left, like towards the middle in the picture below. And for the price of what? Well, not price, for this price in terms of space is what I'm referring to. For its size, you'd have those tower ones that probably take up half of this junction right here. It would take it up like from there to there, then like 2. So that's not really real estate friendly, if that makes sense. And it's why racks are used more commonly. Tower servers are kind of used more for small business because they don't need that big of a footprint. But you do see racks sometimes for space allocation. But I'd argue the one of the things that's a little more, I would say, reasonable about towers is the cooling. They're a little bit easier to cool than these racks because the racks are pancaked and they're about. Zoom out. Let me see if I can grab some space. There's a box. There's a box. All right. So they're about the size of. I know you can't see me. I'm very far away. I'm grabbing a toolbox. Something. They're about this wide, usually. They're about that long, if not almost twice the length. I have pictures of one. Give me a second. Anyways, that's how rack servers are. They're more popular for that reason, and they're a little bit more upgradable, and they usually come with 2 cores. We'll get there. So, after these kinds of racks, towers, there's blade, which I just mentioned earlier. So a blade is, think of it as just this big, the banks on the tower. Think of it as just that with a control unit, and you just plug things in. And each one of these can act as essentially a small server, and that's why it's called the blade. Each blade contains a single server. See, they're all servers. Assigned to one application, the single blade server tends to be dedicated. Admins have greater control regarding how yeah, that's true. So I have worked on blades in the past. Blades are kind of fading out now. They're getting replaced with just racks. Why would they be replaced by racks? Because of virtualization. That's why I had you guys make a virtual server. Because in this day and age, everyone's moving to virtualization. But you can do with this blade up here, for example. Let's count how many servers. 1, 2, 4, 5, 6, 7, 8. So that's 16 servers, right? You can host. This one has. Let's just go with 6, right? So 6 of these servers should be hosted on one rack for real estate purposes and running costs. That is a billion times cheaper. So that's what everyone's preferring virtualization on a rack now. And even towers, you can virtualize to a point and have multiple servers running, but then that becomes a question of resources, which I'm not going to get into. But moving on with server hardware, let's talk about the components. You recognize these components practically because you've seen them before. I'm hoping and praying at this time and day and age of this class, you guys have, we spec'd out our original computer and we're going to spec out a server. It's about the same. So see, CPU, computer processing unit. We all know it. We've seen it before, Windows 10 or what have you, it's there. Memory, it's a big one. You're gonna need a lot of memory because you'll be running a lot of complex tasks. That makes sense. Storage, same thing. The only difference between a PC and a server, I use that in air quotes, because you can expand storage on a server easier with the connector that's called the SCSI connector that you just pop in and go, and it reads it as if it was live. Oh, it does read it as live the moment you plug it in. It doesn't need to be configured. It picks it up automatically, and then you just format and you're off to the races. Versus the PC, you got to take it apart, turn it off. No, with the servers, you plug them in with power on and just go. You skip about 2-3 steps when comparing to a tower. Like I said, storage, that's scalable depending on what you need it for. Databasing, email, yada yada. Connectivity, yeah, that's kind of important. You need to be on the network. It's server. You have clients that you need to reach, and they need information, they need access to things, yada yada yada. You got to administer them, right? That's the point of a server, sharing resources. But within all of this, there's a configuration for storage that's called RAID, which we will get into right now. So what is RAID? It stands for Redundancy Array of Independent Disks. It's a way of storing data in different places on multiple hard disks or solid state drives, which we're kind of now moving towards, believe it or not, just due to the speed. In reality, you've heard me say maybe spinner. When I refer to spinners, it's a spinning drive. I don't have one with me. I'm not in my office. I have plenty I can show you there. Now everything is now a solid state, where it's essentially just this gigantic flash drive, which I do have. It's kind of like, man, this background's gonna kill me. And see there you go. It's kind of works like flash memory, but you can write to it a bunch of times so it burns out. But data recovery on those is kind of a pain because if the chip burns out, a certain chip, figure out what chip it is, they got to solder the chip back in. Excuse me. It pretty works. Sometimes it doesn't, believe it or not, because it's just so far gone and corroded from all the writing, the SSD just gives out. So how does RAID work? RAID works by placing data on multiple disks, allowing input-output I/O operations to overlap in a balanced way. Essentially, it's like a teeter-totter. You're trying to keep level with a bunch of disks, and you're spreading data to a bunch of different places. There's a bunch of different RAID types. I'm going to go over about 6 of them, and I will mention which are still used and which aren't. Don't worry, I'm not going to make a question like that on the exam, but I will ask you about RAIDs in the final. Just Give me a RAID type, what to do. Yeah. It won't be anything crazy. If you've seen the midterm, I try not to make it too hard. And going back to RAID, because using multiple disks increases the mean time, which is average, between failures. That's true. If one disk fails, the other disk should have a backup part of it somewhere and they can recover. Swapping the new disk, again, off to the races. Storing data redundantly also increases fault tolerance. Yes, multiple backup copies are made with RAID. Just depending on the RAID configuration, the backups vary, and that's kind of the point of RAID. There's 0, 1, 5, 6, 10. I think is what I'm covering. Maybe even 3. I think 3 might be sprinkled in. So I made these like 2 days ago, so bear with me, guys. So RAID appears to the operating system OS as a single disk. Yes, this is true. Whatever you can have a configuration of, let's say 20 SSDs in RAID, and they're all 1 terabyte. So that's 20 terabytes, right? Your computer will see it. Let's say it's a C drive, 20 terabytes. That's how it sees it. It doesn't see it as independent disks. All just one big old chunker, one big guy thing. That makes sense. So RAID employs the technique of disk mirroring or disk stripping. I'm going to refer to it as disk stripping. So what disk stripping is it takes, I'm trying to just figure out something I can grab to like as a visual aid. These recollers will work. Let's say these guys, these recollers are data. I'm dumping it into drives. This is one drive. I'm put a piece here. Well, the next drive, I just drop a recoil. Another piece here. And so on, and so on, and so on. Depending on how many disks you got, it's going to sprinkle out the data all over the place. So that if it doesn't see it, it'll back it up to each disk, or vice versa. It can cascade a bunch of different ways. And where was I? So that's what I said. Mirroring will copy identical data onto more than one drive. Yep. So if disk 1 has part 2 will have part 2 and 3, and yada yada yada. It'll just keep cascading up and up, and backwards and forwards till they all have their data synced for backups. Stripping partitions. So when you sprinkle data, helps spread data over multiple disk drives. Each disk drive storage space is divided into units ranging from a sector of 512 bytes to several megabytes. Yeah, the sizes vary depending on the kind of data. The strips of all the data are interleveled. I can't read today, and addressed in order. So part 1, part 2, part 3, part 4, part 5, yada yada. All bunch through this. Disk mirroring and disk stripping can also be combined in a RAID array. That's what we're getting into. But that's how RAID works, and that's what RAID is. In order for RAID to function, you need to have something called a RAID controller. So it's a card. If I find a picture of one, which I forgot to kind of grab, I'll chuck it in the slides, so it'll be updated when you guys get it over the course of the weekend. So a RAID controller is a device used to manage hard disk drives in the storage unit. Yeah, that's essentially what it is. It's just a control unit for your RAID. It can be used as a level of abstractions between the OS and the physical disk, presenting groups of disks as logical units. Using a RAID controller can improve performance and help protect data in case of crash. So this is more for a server than it's for a regular PC. You can run RAID on a regular old PC, but it's rare nowadays. That was more popular back early 90s. Nowadays, it's all, like, again, it's server, right? So it's all server-based. Now, RAID controller can be hardware or software. In a hardware-based RAID product, a physical controller, it's a card, manages the entire array. So it's just one card that's in charge of it as a unit. The card can also be designed to support drive formats such as serial events, technology attachment SATA, or a small computer system interface, SCSI. That's where SCSI comes from. A physical RAID controller can also be built into the server's motherboard. Yeah, that's part of it. It's usually baked on now. The cards aren't technically extinct because they're still supported in a bunch of different servers, but they're starting to bake them in more because it's cheaper. Why spend extra, let's say $300 for the card when it comes built in and it only costs $150 to bake it in, and then they charge you the difference. They still make their money. But with software-based RAID, moving on, the controller uses the resources of the hardware systems, just central processing unit memory. So if you're using a software-based RAID, which is still around too, that's used more in virtual now because you can't really have a card in the virtual machine, right? As you've seen, we don't have hardware we can touch inside a virtual machine because even though it's on your tower or laptop or whatever, you can touch it. But I'm referring to the machine in the box, and it uses the hardware systems, which is the CPU and memory. I need to add SSDs into the point before, so that I will make a note of that. Give me a second while I bring that up. And make a note because Mr. Al is having a very rough Monday, and it's the first day of our semester at Santa College. SSD to slide 9, and then okay. There's that. Sorry, guys, it's been a rough day today. So give me a second here. What was it talking about? Software-based RAID. So if it's the same as hardware-based RAID, that's true. Software-based RAID controllers will not enable as much performance boost. That's kind of true because it's being emulated. So that's just based more on your hardware that's already there if you don't have the card. So that's going to be the main deciding factor. And then firmware-based RAID controller chips are located on the motherboard. Yeah, I know. And sorry, let me rephrase that. Firmware-based RAID controller chips are located on the motherboard and all operations are performed by the This is just telling you how software-based one works. So they're going to have chips on the board that can do it or mimic it. And it's controlled by the CPU and software-based RAID. However, with firmware, the RAID system is only implemented at the beginning of the boot process. So RAID only accounts for when the computer starts. That's what it's essentially telling you. It's not going to run the entire time. Once the OS has loaded, the controller driver takes over RAID functionality. Firmware RAID controller is not as pricey as hardware, this is true, but it puts more strain on the computer CPU. Firmware-based RAID is also called hardware-assisted software RAID, hybrid model RAID, or fake RAID. Yeah, that's true. It's not really the true RAID. The true RAID will be the card, the baked-in card, or even software-based to an extent. It's considered more of a true RAID than firmware-based RAID because it's software versus firmware. Firmware is just basically cooked into the board versus software you can add, edit, change, do whatever. Technically, you can do that with the board if you melt on new chips, but that's a whole different animal that people don't really go and do. What's rare. Unless you have an HP board and the video card's failing, you don't bake stuff that often anymore. And that's electronic repair. We're not here for that. So now we're going to talk about RAID levels little by little, but I'm going to talk about devices and stripping and RAID a little bit more. So moving on. Let me grab some water. My voice is going hoarse. Give me a second, guys. All right. So RAID level. RAID devices use different versions called levels. So I was referring to them as RAID 0, RAID 1, RAID 3, RAID 5, RAID 6, RAID 10. The original paper that coined the term and developed the RAID setup concept defines 6 levels of RAID, 0 through 5. We have not gone through 10. It's up to 10. There's no 8. No, it's called 10 because it combines 1 and 0. This number system established those in IT to differentiate RAID versions. So when they came up with this paper about, I'll say late 80s, mid 80s, it was just a theory and they just put it to test and they made it work. That's why it was just made to help you. It's a standard. Sorry, my phone just went off. Kind of like the OSI model. It's kind of similar in that concept of it's kind of like a checklist of this, how this works, this how that works, this is what's here, this is what's there, this is RAID 1, this is RAID 2, yada, yada, yada. Kind of like there's a physical layer, transport layer, application layer, in the same kind of sense for RAID. This is RAID 1, this is RAID 0, RAID 3, RAID 5, etc. There are levels have since expanded, that's why I said that, has been broken into 3 categories: standard, nested RAID, which is a combination RAID, that's RAID 10, and non-standard RAID levels. Non-standard, I'm not going to really mention because they're not really seen that often anymore. They've totally been phased out for the standard and nested. It's just for terms of redundancy and costs, believe it or not. It's usually cheaper to run standard and nested than it is non-standard because it's so out of the box. There's no point of it having it. So if you heard me mention stripping before, it's just definition of stripping. Stripping a RAID is the process of dividing a body of data into blocks and spreading that data blocks across multiple storage devices. Remember I said sprinkling and I have the Ricola and this is a paintbrush thing. It's like I paint, I'm a nerd. And just moving the data around from spot to spot where it's saving spot 1, spot 2, spot 3, spot 4, and a bunch of different drives, little by bit, byte by byte by byte, block by block. That's what stripping is. So when you hear me say stripping, I'm referring to that of just spreading the data around to multiple storage devices, okay? So the first RAID I'm going to talk about, and I'm not talking about the movie or RAID 2, the other movie. Trust me, finding examples or pictures of RAID brought up a lot of the RAID movie. This is like from 2012. The RAID movie, not RAID. So this is a standard level of RAID. RAID 0, the configuration is stripping put, but no redundancy. So when you're in 0, it just puts the data in both spots, but they can't back it up. There's nowhere else to put it. It offers the best performance. It is the fastest. This is true, but it does not provide fault tolerance. So that's the problem with not having, we're using RAID 0 is there's no backup. So if this crashes and burns, let's say you have a media server, perfect example. That's 8 terabytes, 2 4 terabyte drives, right? They mirror each other back and forth. It sounds like I've almost been through this before, which I have. And they mirror the data back and forth, so you're running your RAID 0. But one of the drives burns out and crashes. That data is lost unless you get a very expensive platter machine, take it apart, recover the data. At that point, you're spending over $1,000 to $3,000 alone. That's why RAID 0, while it may be the fastest, it always keeps things moving, which is great. It keeps the data, it's integral, it's there, but there's nowhere to store or back it up. So moving on from RAID 0, we got RAID 1. I know it sounds really numerical, really simple. So RAID 1, also known as disk mirroring, this configures at least 2 drives that duplicate the storage data. So it's like RAID 0, where it shares the data back and forth, but this one backs the data up to all the areas. There is no stripping. Read performance is improved since either disk can be read at the same time. Read performance is the same as for a single disk. So it sees it just as one disk and they read it almost as one disk. So that's RAID 1. RAID 2, on the other hand, pardon me, there's something in mind, gets kind of complex. This is where stripping really kicks in. So you have disks 1, 2, and 3, and then they RAID over to disks 4 and 3. Sounds kind of simple. 3 is stripping across disks, so all of it gets stored all over the place. 1 to 1, 2 to 2, 1, 2, and all that. And data correcting, error checking and correcting. So that's kind of important information. So what winds up happening with some of this do stop, or some of this store error checking, which would be the ones in the end, as you can see, ECC error checking. RAID 2 also uses a dedicated hammering code, partially a linear form of ECC. RAID 2 has no advantage over RAID 3 and is no longer used. RAID, this got faded out really fast after it became popular. This, like, what, late 90s, turn of the century, new millennium, practically. And it just moved on from it because RAID 3 is what kind of took over the party, and I will show you RAID 3 moving on. I know this RAID 2 example is not really the best. It's the best I can find, guys. I'm sorry. So RAID 3, this thing uses stripping and dedicates one drive to storing priority information. So all the stripping, it gets saved to this 3. That is your backup. The embedded error correction checking information is used to detect errors. So if it detects an error, just 1 or 2, it will pull the backup copy of it from disk 3 and throw it in. Data recovery is accomplished by calculating the exclusive information recorded on the other drives. Because an input-output operation that addresses all the drives at the same time, RAID 3 cannot overlap input-output. For this reason, RAID 3 is the best for single-user systems with long record applications. So if you're using a database, this right here is what will save your butt. Even though you can't overlap input-output for users or writing, if it's in, let's say, an inventory SQL database, I may be going over your head, but it stands for Structured Query Language. And you have this database, you have all your computer information on it from where you work. It stores the manufacturer, the model, the make, the asset tag. That's what I have at work. Ours is SQL. But my point is, it stores all the information for you, who has it, when it was deployed, when all that's in there. It's on disk 1, 2, but it backs up to disk 3 nightly. It compares all the inputs and outputs from the day. So you could technically write a script that will do this at 10 p.m. at night when nobody's at work other than janitors, right? So they're going to use their own computers for their work orders, but nothing else. There's no data being processed for students, data being processed for applications or AutoCAD classes or anything of that kind of nature. You can have a script run and go over the network and check for anything that connected to it that was new, that belongs to the wherever you work. And if it matches the naming convention or whatever have you, it pulls the information, writes it all at once in one go versus little bits, so it can't overlap, because that's what it can't do. And then it'll back it up incrementally into disk 3 over the night, and it'll be done by the time you come the next day. And this is more for databasing. That's why RAID 3 is pretty important. That's why it's pretty popular too. If your server is doing a bunch of roles, so if it's doing mail, if it's doing a print server, can it do overwriting for input output? No, because it's a bunch of different services going at once. That's why this is used for databasing. I'm just trying to make that clear, trying to hammer that point home, because this is pretty important in that aspect. So RAID 4 looks similar to RAID 3, it just adds another disk in. But this uses large strips. Strips. Sorry, stripes? I think it's strips, whatever. Which means the user can read records from any single drive. Overlapped input-output can then be used for read operations, because all write operations are required to update the parity drive, which is your backup drive. No input-output overlapping is possible. So what it's saying is you can read from all of this at once. So it's going to be super quick at gathering your info, bringing it back. And input-output can overlap a little bit, but it's only read. It's not stored. That's the thing. That's kind of an issue because it can't overlap regardless still. So that kind of sucks. But it kind of works, because this is more for bigger kinds of databases that I'm not going to get into and have you guys get lost, like Docker and AWS cloud stuff. It kind of runs on RAID 4 and 3, mostly 4. But moving on. RAID 5. See how the parity disk D, C, B, and A are spread out? This is done for a reason. So this guy uses parity block level stripping. So it strips those blocks, those big parity parts. The parity information is stripped across each drive, which I just said, enabling the array to function. Even if one of the drives were to fail, the array's architecture enables read and write arrays to span multiple drives. What's that mean? So let's say this guy fails, it can still read from here, from A, B, and C, and it'll be fine. It even could have been the backup for parts of it. It'll pull what it had prior from a backup in C1 or in B2, wherever it has C3, and it will still continue to function. The result is performance better than that of the single drive, but not as high as RAID 0 array. RAID 5 requires at least 3 disks, but it is often recommended to use at least 5 disks for performance reasons. That's kind of why they call it RAID 5. It's 5 disks. They had to think of something. RAID 5 arrays are generally considered to be poor choices for use on RAID-intensive systems because of the performance impact associated with writing parity data. When a disk fails, it can take a long time to rebuild a RAID 5 array. Yeah, that's true. So this is not something you use for databasing. That's what's telling you when it's a poor choice for write-intensive systems. Databasing is very write-intensive because it's just doing a bunch of number crunching, what have you, and information gathering, information input, information storage. It's a lot of writing to a disk. We don't use RAID 5 for that. RAID 5 is more for, I'm trying to think where you can use RAID 5. I mean, it's kind of slow. Research, actually, and some server applications you can use it for backing up stuff. I'm trying to think where I've seen it. I have seen it in public, but this was many moons ago. I don't even think they're running it anymore. But now let's go to RAID 6. So give me 1 second, guys. I need some more water. Be positive real quick. All right. RAID 6. It's similar to RAID 5. This is true. But it has a second parity scheme distributed across the drives in the array. What does that mean? So here this is P, that's parity. Q is the backup of the parity. So there's another one. So it's 2 per every disk. So use of additional parities enables the array to continue functioning. This is true. That's why if 2 disks fail simultaneously, 2 disks fail, let's say disks 1 and 2 fail, you can still read 3, 4, and 5. You're good. You're golden. It works. However, this extra protection comes at the cost. RAID 6 arrays often have slower write performance than RAID 5 arrays. So it's not as slow as molasses, but it's pretty slow. I don't know how true that is anymore with SSDs. I haven't built a RAID with SSDs up to this capacity. I would argue it'd still be pretty fast, but don't worry, I'm not gonna have you guys go spend money on SSDs to try. To try this. Well, let's keep going, right? Let's talk about nested RAID. This is RAID 10. This is the big boy. This is the guy we wanted to get to. So nested RAID levels. Some RAID levels are based on a combination of RAIDs, because that's what I said in the very beginning. RAID 1 and 0 are combined to form RAID 10. Combining RAID 1 and 0, that's what Lodi just stated, this also referred to as RAID 10, which is what I've been saying, which offers high performance than RAID 1, but is at much higher cost. In RAID 1 plus 0, the data is mirrored and the mirrors are stripped. So it backs it up, strips it, sends it everywhere else, backs it up. It's just continuously doing this. That's why it's called RAID 0 and RAID 1. RAID 0 is on the left, RAID 1's on the RAID 1's on the front, RAID 0 on the back. That's 10. That's essentially all I have for this one in terms of RAIDs. So I'm going to stop the recording here. The next one I'm going to talk about hardware, but physical hardware. It's pictures, and I'm going to get into it a little more. We're only at slide 18. We've got about 20 more slides to go because I have to cover maintenance as well. But I am hungry, so let me grab some dinner, and I'll be back with you guys in about 30 minutes to record the rest. All right? So until then, guys, take it easy. You can stop here for right now and answer some of the questions I have in the homework. And you even do the lab, which I'm still thinking about, which I don't know what it's going to be at this point, but it won't be anything related to this stuff. It'll be a super simple lab. You're coming off of a midterm. I get it. You're tired. I'm trying to work with you guys. So, gotta be fair. You can't just, tell you guys to answer a bajillion questions on a midterm and create me a DNS server with DHCP and all. No, we're not doing that. We'll do some other server stuff. It'll be light. Okay, enough of me rambling. Time for dinner.